All right, guys, so we have this problem where it's asking us to maximize a function. So this particular problem says maximize q, where x and y are positive numbers, such that x plus 16/3 y squared is equal to 25. Just a second. Okay, so here's the thing. Here's my problem. When I first looked at this, I said, well, I have a function q up there, and all it has is x and y. And it's not really telling me much information. So what we really have here is a system of equations. Um, so from prior knowledge, from what I know about systems of equations, I know that I can solve an equation when it has maybe one variable in it. When I have one equation with two variables, then I run into trouble. Okay, so what I have here is two equations, two variables, which means that what I can do is take one of these equations, in our case, the second one, the x plus 16/3 y squared equals 25. What I'm going to do there is solve for a variable. So I'm going to solve for x. So I'm going to write that equation down. And think about systems of equations. If I solve this equation for x, I get a value for, or an expression for x, then what I can do is substitute that expression into my other equation, and that's going to help me out. So that's what I'm going to do here. I'm going to solve for x for my first step, and that leaves me with x is equal to 25 minus 16/3 y cubed. Y squared. Why am I putting cubed? I'm glad I'm catching myself. I don't have students to remind me. Y squared. Okay, so I'll solve for x. Now, I've already kind of given you a heads up as to what I'm going to do next. My next step is going to be to substitute. So let's use a different color. So I know what I was given was that q is equal to xy, and now I have an expression for that x. So I can actually substitute that expression in the place of that x there. So I'm left with q is equal to y times that 25 minus 16/3 y squared. All right. Now, I'm going to expand this a little bit up, just so I don't have any parentheses, and which means I'm going to have to multiply this. That's going to give me 25y minus 16/3 y cubed. So now I have an expression that looks more familiar to me. I have one variable in there. I know what q is equal to. Now let's think back to what we are trying to do. We are trying to find the maximum. We want to maximize this function. So how do we find the maximum and minimum? That's our relative extrema. The way we're going to find it is by finding our critical values. To be able to find our critical values, we must first find the derivative. So let's take the derivative of this function. So let's use a different color so we know I'm doing something different. I want to find the derivative. So q prime of this function will be 25 minus 16y cubed. Now, once I find my derivative, I want to find my critical values. And how do we find our critical values? Well, we take that derivative. You take the derivative, and you're going to set it equal to 0, and then we're going to solve it. So what I would probably do is bring that 16 across, that negative 16, which would give me a positive 16, y squared. Divide both sides by 16. Y squared is going to be equal to that 25th 16th. And I want to get rid of that squared, so I'm going to take the square root of both sides. So that leaves me with y is equal to positive and negative 5/4. So guys, I have my critical values. So I have some things going on there, possibly maximum and minimums, right? Now we got to think about what's going on, or um, let's see. There's a couple different ways we could do this. Well, when I follow the example, I like to look at these examples and see how the book runs through it and see how they work it out. But if you notice, my highlighter is kind of covered up by this app that I'm using. But this tells me that my X and Y are positive numbers. Well, what I have right now is one positive and one negative value. Now, if you follow the Help Me with my math lab, they go through the second derivative and try to find your max and your mins. Um, but I think I could do this a little bit differently. What I'm going to let's make a note that we would throw out negative 5/4, because in the problem it told me that X and Y were both positive, so I can't have a negative value. So what I need to do here, I need to test to make sure a 5/4 is a maximum. Now, how do I test to see if it's a maximum? Now, I can use the second derivative for that. So I'm just checking myself. I'm assuming that's the number I need. It's the only one I could possibly use. But I just want to check and make sure that that positive 5/4 would give me a maximum. Remember, your second derivative tells you if it's concave up, concave down, right? So let's find our second derivative. The second derivative of Q, if you look back, is going to be negative 32y. Now, if I take my positive 5/4 and plug in, then that's going to give me negative 32 times positive 5/4. Guys, I don't really care what the actual number is. Remember, I just want to know the sign. This is going to be a negative number. Negative numbers, negative values, means it's concave down, which means I do have a maximum at, what did I plug in? Y equals, or when, not at, let's say when y equals 5/4. Well, okay, I've got somewhere, but I need to know the actual entire ordered pair. Well, if I know what my y value is, I can very easily figure out what my x value is. And I know I'm moving a lot, but on your paper, you have an equation up here that allows you to find your x value. You know that x is equal to 25 minus 16 thirds y squared. So if I come over a bit, that also tells me that x is going to be equal to 25 minus 16. Erase this. Let's go through this one step at a time, because I have a feeling I just put the wrong value down. So this is going to be x equals 25 minus 16 thirds, and that's going to be 25 times 16. Um, um, and if I simplify this is going to give me x equals 25 minus 25 thirds. And again, that's going to give me x is equal to, I don't have a calculator here, so we're going step by step. That's going to give me 75 thirds minus 25 thirds, which is going to give me 50 thirds. So there's my final answer, okay, for x. So okay, I know where my maximum value occurs. I have a maximum value, my maximum occurs when I have this for x, when I have 5/3 for x. Let me get my pen. My maximum occurs when I have that 50 thirds for x and I have that positive 5/4 for y. So using the original equation, I need to find my max. My max is going to be found by using this function. So my max for my q function is going to be found by multiplying 50 thirds times that positive 5/4. And if I multiply that together, that is going to give me 125/6. So the way I would write that, let's sum this up and write it very neat, nice, and in order. So what I have down is that thus we have a maximum value of 125/6 at 50 thirds and 5/4. And that, my friends, is it.